All right, welcome to Physics 30. I think I will actually type this up and have it printed out for you, but I'm going to write it out down here. And by what I mean by that is I'm going to write out a method for solving physics problems. Now, it's not that you necessarily need to use this method all the time, but I tried to come up with, and I mean, I've gotten this over the years from other teachers as well, but tried to come up with a bulletproof method to solve any kind of, or to approach any kind of physics problem. And so hopefully these will be quite useful now, and if you end up going to university and taking any kinds of math or science, that this will also be a very good method for you. Especially if you're used to just looking at a question and trying to figure it out on your calculator and throwing down an answer, this is a much better method because it lays out your thoughts. And so anyway, let's go through the different steps. So step one is to draw a diagram if needed to help clarify the situation. Often the question, you'll read through it and you'll be like, I barely understand what's going on. So what you do is you start by drawing a diagram. Now I put if needed because if the question is so simple, there's no point to drawing a diagram, or the diagram would just be kind of like, just so obvious, like when you read it, you imagine that exact thing, then don't bother to draw a diagram. It's not necessary every time. Second step is to state the given variables with their values and units. So the given ones, very important, put the value down and the units, and the unknown variable, and I suppose it could be more than one variable, so variables that you're trying to find. And both of these things are basically the setup. So when you're setting up your question, the solving part of your question, I guess the solving part of your answer, you should do these things. You should draw a diagram if needed, and only if it's going to help out. And then the other thing is you need to state down all the variables are given and all the ones that are unknown and that you're trying to find. Okay, there will be at times too where it doesn't seem like there's some variables that aren't necessarily given but are implied. Like for instance, if I said, calculate the initial speed of this pen is, let me just say, if I drop this pen like this, there's a couple things that are implied, and that is the initial speed is 0, and that also that the acceleration that the pen is experiencing is gravity, which is 9.81 meters per second squared. So those kind of things also would be part of the given variables, even though they're kind of almost hidden variables, or not stated clearly. Okay, and the third thing to do after you've written down all the variables you have and the ones you're trying to find, you should state the formula. And might be formulas that you are going to use. And this is the most difficult thing, I would say, for most solving, is actually stating what formulas can actually help solve it. Okay, so this sometimes this just takes practice. It's not always obvious, and sometimes you have to use, like, these are the equations that I've given you. Sometimes you have to use all 4 of these equations. So just to solve for one variable. Modify. So modify them. Modifying the formula is like rearranging, that kind of thing. So the unknown variable is on the left side of the equation. And why on the left side? Just because I like to do that. And most people read left to right. And so, for instance, if we went v bar is equal to delta d over delta t, here is a really nice equation if you're trying to solve for v bar, or the average speed. If you're trying to solve for delta t, then I'd suggest to rearrange it so it goes delta t is equal to delta d over v bar. And if you don't know how I rearrange the equation to make this, don't worry, we're going to do that. And that's the kind of thing that hopefully you paid attention to in math class, and I'll show you how to rearrange variables across an equation. And this step, this stage, I guess, of the steps, we say this is when you figure out how to solve the question. And really, this is the hardest part, figuring out, okay, we are given this stuff. Sometimes this is the hardest because there's some hidden ones, but then this is usually the hardest part, and that is, how are we going to figure this out? What equation are we going to use? How are we going to rearrange the equation? Okay. Once you've gotten this done, step 4 and step 5 are actually rather trivial, kind of boring. 4 is you just substitute the values, and units for the known variables, and 5 is you calculate it, or you can say deal with numbers and units. Okay, and it's simple as long as you know to use your calculator. Or you can use, you're at home here, you can use your computer, you can go online. I can show you some different sites, or I can suggest some sites that you could use to calculate. You can put in equations. I can't remember the name right now. It'll come to me. I'll let you know when. There's a particular site that's really nice for calculating things. Something alpha at the end of it. Shoot, I forgot. Okay. Then you're going to record the answer in scientific notation, and I'm just going to say if needed. And you might be thinking, well, why would I need to put in scientific notation? Well, if the answer is super large or super small, you should use scientific notation. Also, if you need to show how many significant digits, like say your answer ends up being 100, and you, like 100, let's say meters per second, and you really need to show that there's 2 significant digits but not the third, then you should write it as 1.0 times 10 to the 2 meters per second. So, and I can explain that a little bit more too. So if needed, put in scientific notation and with the appropriate significant digits. Okay, and there's some actual, I don't know, maybe we haven't done this yet. Significant digits. I think just before we left Vanier, I handed out a sheet that had that, like when you multiply, divide, add, but I don't think we got to talking about that. So when we go through some questions, I'll try to explain that too. And then remember to include units. And you're not just including units to be nice. This is very important If I say the answer to something is let's say 12, even if I say, oh, how much, if you say how much time was it? Well, 12. Well, 12 what? 12 years, 12 seconds, 12 minutes, 12 microseconds or nanoseconds. All you need to have units. So if I say, oh yeah, microseconds, well, that's a big difference between, say, 12 weeks or 12 days or 12 years. So make sure to include your units. Okay, I'll make a third video here, and I'm gonna start solving the questions on the worksheet here with distance, speed, and acceleration.